Hello ladies and gentlemen, this is Mr. McNair, and this is going to be a short video over the questions from the the final review packet that I gave out over Chapter 9 questions. Here are the answers for Chapter 9 questions. Here's 59 through 64. You can pause that if you need to. Here are the questions 65 through 70. Once again, you can pause if you need to. All right, so let's go over a select few problems here. This problem says find the next three terms in each geometric sequence. Geometric sequence has a common ratio between the terms. All right, there's a number that you can multiply by to go from one term to the next. And we see here that the number that we're constantly multiplying by is -2. Okay, -1 times -2 gives you +2. 2 times -4 gives you, 2 times -2 gives you -4. -4 times -2 gives you +8. So all we're going to do from there is just keep on multiplying by -2 to get the next three terms. So from 8, if we multiply that by -2, we get -16. If we multiply -16 by -2, we get +32. We multiply +32 by -16, we get -64. All right, so those are the next three terms in our geometric sequence. All right, now sometimes the issue might be with actually finding out what that common ratio is. Like, what's that number that you multiply by to go from one term to the next? Well, if you don't know what the common ratio is, you can always find the common ratio by taking one term and dividing it by its previous term. Like here, we could do 2 divided by -1, and you'll see that gives you -2. That's the common ratio. Even if you didn't pick those two, let's say you picked 8 and -4. Well, 8 divided by -4 gives you -2. That's the common ratio. That's the number you're multiplying by to go from one term to the next. Okay? 61. What is the 13th term of the geometric sequence? 8, -16, 32, -64. Now, there's a formula that I gave you guys for this. It was a sub n equals a sub 1 times r to the n minus 1. All right. Now, a sub 1, that means we're talking about the first term of the sequence, and we see that the first term of the sequence is 8. Okay? R, once again, is the common ratio. All right, what number are we multiplying by to go from one term to the next here? Well, actually, we're multiplying by -2, just like we did in the last problem. All right, that's purely coincidence. It's not always going to be -2. All right, so n is the term that we're looking for. So in this problem, we're looking for the 13th term. So we're looking for a sub 13. All right, that just means the 13th term. So to find the 13th term, we take a sub 1, the first term, and our first term was 8, multiplied by the common ratio, and we said the common ratio was -2, and raise that to the n minus 1, so that's 13 minus 1. And we know that 13 minus 1 is 12. So we're just going to simplify that right away. When you plug all of that in your calculator, the value you get out is 32,768. So that will be the 13th term of our sequence. All right, moving on. Graph each exponential function. All right, when I told you to graph an exponential function, we first pick some values for the x. The values that we generally pick are -2, -1, 0, 1, and 2. All right, then we take these values and we plug them in. We plug these values in for our x so that we can get our y. So when you plug in -2, the value that you get out is 2/9. When you plug in -1, you get out 2/3. When you plug in 0, you get out 2. 1 gives you 6, and 2 gives you 18. All right, now because I noticed that we were dealing with all positives on our y values, notice again that I only dealt with quadrants 1 and 2. Okay? And then also because I noticed that my highest y value was 18, I decided not to count by ones. I went on ahead and counted by twos. So let's go ahead and plot these values. -2, 2/9. That's going to be really, really close to 0. -1, 2/3. Well, that's going to be around about here. Remember, we're counting by twos, so 1 is like right there. So 2/3 is a little bit below that. Well, a third of a way below that, actually. Exactly. 0, 2 is here. 1, 6 is here. and 218 is here. Okay? And then we go ahead and we connect our dots with a smooth curve. Now, I do want to make sure that you understand this concept too. Please remember that these graphs, they do not cross the x-axis, and they don't touch the x-axis. Remember, the x-axis for an exponential function, for many exponential functions, is an asymptote. Okay, meaning that it gets closer and closer to it, but it never touches it or crosses it. All right, moving on. Number 66, you invest $1,000 at a rate of 3% for 5 years. How much would you have in the account if the interest was compounded in the following ways? All right, this problem was broken down into three. We'll be doing annually first, then quarterly, then monthly. All right, so let's go ahead and deal with our annually first. So the formula for annual interest is compound annual interest is y equals c parentheses 1 plus r to the t, where c is the initial amount, r is the rate given as usually given as a percentage, but it needs to be a decimal, and t is time. So here our initial amount was $1,000. Bringing that 1 plus r is 0.03, raised to our time period. Our time period was 5 years. Okay? Now if we simplify that, that's 1,000 times 1.03 to the fifth. And if you type that in your calculator, 1,000 times 1.03 to the fifth, the value that we get out is $1,159.27. Okay? And there we go. We've calculated annually. All right, let's do these same values, but this time we're going to do it quarterly. When you're doing something, when you're doing compound interest and you're doing something that is not annual, and you take interest more than one time a year, the formula that you're going to be using is y equals c parentheses 1 plus r over n to the nt. Okay, where n is the number of times you take interest within that year. Quarterly means that you're going to be taking the interest 4 times. So let's plug our values in. Y equals, again, our initial amount was 1,000. 1 plus our interest is still 3%, so that's 0.03. And once again, we're compounding this 4 times a year. So that's going to be 4 raised to the 4 again, because n is 4, times our time period is still 5 years. All right, let's simplify. When you type 0.03 divided by 4n, you get 0.0075. So this simplifies to 1,000 times 1.0075. And 4 times 5, we know that is 20. All right. Now 1,000 times 1.0075 raised to the 20th power gives you $1,161.18. Okay. Great. So that was quarterly. We're going to use our same formula for monthly. All right. Now monthly, if you're going to do the compounded monthly, that means that you're going to be taking the interest 12 times in the year. So using the same values, except this time instead of n being 4, we're using n equals 12. Our initial amount is still 1,000. 1 plus our interest rate is still 3%. This time we're taking the interest 12 times a year. So 12 times 12 is n, and we're still for 5 years. 0.03 divided by 12 is 0.0025. So this simplifies to 1,000 times 1.0025 raised to the 12 times 5 is 60. 1,000 times 1.0025 to the 60th, that equals $1,161.61 or 62 cents. All right, banks don't round up, so I'm just going to go ahead and round down. So $1,161.61. Okay, great. So once again, annually, quarterly, we use 4. Monthly, we use 12. Okay. Fluorine 20 has a half-life of 11 seconds. Find the amount of fluorine 20 left from a 40-gram sample after 44 seconds. So the formula that I gave you for this is similar to our compounded formula, except we know that it's going to be a half-life. So this is our formula. Half-life, you're going to use 0.5 as the decay rate. Okay? So from there, we're just going to go ahead and plug in our values. C is the initial amount. The initial amount was 40 grams. Okay, times zero point 0.5 to the t. Now t is tricky here. Okay, t is not the overall time period. T is the number of half-lives that go into the time period. So fluorine has a half-life of 11 seconds. We want to know how much is left after 44 seconds. So how many times does 11 seconds go into 44? Well, that's 4 times. All right, there's 4 half-lives that go into 44 seconds. All right, so that being said, we have 40 times 0.5 to the fourth, and we'll be left with 2.5 grams. Just to kind of explain that whole thing about time period, let's think about this. We're starting off with 40. After 11 seconds, we're going to be half as much. It's half-life. So that'd be 20 seconds. After another 11 seconds, you'll be at 22 seconds. You'd be at half of that, which is 10. After another 11 seconds, you'd be at 33 seconds, which would be half of that, which would be 5. And after another 11 seconds, you'd be at 44 seconds, and you'd be at half of 5, which is 2.5. And that's what we got here, 2.5 grams. Okay? So that's why we're looking for the number of half-lives that go into the time period. Great. All right, last one here. Write a function that models the data, then use your function to predict how long the humidifier will produce steam with 10 quarts of water. First thing you want to do is find out if this is a linear, quadratic, or exponential function. You know that it's linear if the first differences are the same, quadratic if the second differences are the same, and exponential if there's a common ratio between the terms. All right, from here to here, we know that we add 1.5. Here to here, we added 1.5. Here to here, we added 1.5. So we see that the first differences were the same. So therefore, this is a linear function. All right, we know that all linear functions are written in the form y equals mx plus b, where m is the slope and b is the y-intercept. We could tell what the slope is from this problem because we're increasing by 1.5 every time we increase 1. So slope is the same thing as rate of change. So we increased 1.5 every time we went up 1. So that was, our slope is 1.5. All right, from there, we pick a point so that we can solve for b. Because we know the m, we just need to know what b is now. So I'm going to go ahead and pick the point 4, 6. All right, notice this is your x, this is your y. So when you plug in 6 for y equals m, which is 1.5, times x, which is 4, plus b. B we don't know, so that's why we keep it b. If you simplify 1.5 times 4, you get 6. Solve for b, subtract 6 from both sides. You see that b equals 0. So our equation is y equals m, which we know is 1.5, x plus b. Now, do you have to have that plus 0 there? Obviously not, because anything you add 0 to is still itself. So that right there is our equation. All right. Now, the last part of the problem says, use your function to predict how long the humidifier will produce steam for 10 quarts of water. So we're just going to plug in 10 for x. So y equals 1.5 times 10. And we would find out that 10 quarts of water would allow us to produce steam for 15 hours. Okay, and there you go. Hopefully this video has been helpful to you, and good luck studying for your final exam.